Okay, you mathematicians, let's get this started. We are going to be solving equations with radicals. The great thing about solving equations with radicals is that students typically love this part of the unit because it makes more sense and we're using the rules to get an answer. So we are going to be going through oh goodness, so those are all the things we're going to be going through. Okay. We are going to be going through all of these objectives. If you would like to write them down, you are welcome to. Otherwise, you do not need to. We're going to start by doing the power rule. Go ahead and hit pause and get all of this down. The power rule is basically saying that if we have something like this up here, that the square root of x is equal to 3. If we square both sides, that answer is going to give us the same answer as the original. The biggest thing that we need to be cautioned with is this right here. We need to make sure we check our answer. You will be required to plug it in. So if you write nothing else on this part, you write down, you have to get an answer and plug it back into the original to make sure it works. Okay, so this is our first example. Go ahead and hit pause and get this down. Alright, so I'm going to go ahead and square both sides, and the reason why I'm squaring both sides is because this right here, I want to get rid of that square root. So this undoes this, and we end up with 5x plus 1 is equal to 16. So then I want to subtract 1 from both sides, and I get 5x is equal to 15, and then I want to divide by 5, and I get x is equal to 3. I'm not done. I have to check my answer. So to check my answer, everywhere I see x, so all that stuff we learned in the functions unit is going to come into play. Everywhere I see an x, I'm going to replace with that 3. So typically I will write this with parentheses. Oops. Typically I'll write this with parentheses to make sure I do this correctly, and you'll see that going forward. So then we get 5 times 3, which is 15, plus 1, which is 16. We have the square root of 16 is equal to 4. Well, 4 does equal 4, so this is true. So in my answer, this is a true thing. So x does equal 3 for this one. Also, up here, this was linear, right? This was just a linear equation. Lost my linear equation. And so that means it's just a line where we get all the x's on one side and the numbers on the other. All right, go ahead and write this down. You're going to want to hit pause. You're going to want to write the bold things unless you don't know what it means. So if we're going to do step 1, isolate the radical. If you don't know what that means, it tells you. Make sure that one radical term is alone on one side of the equation. So go ahead and hit pause and get those down. All right, so now we're going to do this. So the first rule is to isolate. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So that's how I got the square root of 5x plus 3 is equal to negative 2. Now, I want you guys to think about this. Now, in our heads, we might jump to, I need to square both sides so I can get the inside out. And you can do that, and it will work. But what do we know about things with an index? When I have an index that's even, so this one says 2, right, when there's nothing written down, can it ever equal a negative number? No. A square root can never equal a negative number. So when I find the square root of 36, it can never equal negative 6, right? It's always going to be positive 6. So since I know that, there are no solutions to this equation, and the reason why there are no solutions is because a square root cannot equal a negative number. So that's what this says, no solution. So if I were asking you to write the answer, I would say no solution. Make sure you know that. Make sure you don't lose that logic. Don't get that taken away from you. So go through that. All right, now we're going to do stuff that requires additional steps. So those first 2 examples, those were progressing level equations. This is going to be meeting. Everything we do from here forward is going to be meeting. Okay, so our first step, we want to do step 1. Our radical is already alone, so we can see that. Oh man. Our radical is already alone, so now I'm going to square both sides. Now be careful right here. I have every test we've taken this year, at least one student in every class has made this mistake. we have an x plus 1, which is a binomial. When I see a binomial, I should be thinking I need to put this in a box, because I want to do x times 1, x plus 1 times x plus 1. So then I'm going to get a trinomial as my answer. So if I fill out that box, so go ahead and fill out that box, you should get x squared plus 1x plus 1x plus 1, which gives me an x squared plus 2x plus 1. Alright, so now I got to think to myself, I got to solve this. The new equation right here is a quadratic. Let's take it to the second power. To solve a quadratic, I always need to have it equal to 0. So I'm going to subtract 5 from both sides, and I'm going to add an x to both sides. Okay? So when I do that, this turns into a big fat 0, and then I end up with 0 is equal to x squared plus 3x minus 4. Now students in my class asked me, why would you go the other way and not move the x squared to the other side so it can all equal 0? Well, the reason why I did it is out of pure laziness. I like my x squareds to be positive, and I will, if I'm going to move left or right, I might as well keep it positive because it makes it one less step I have to do at the end. Alright, so now when we're thinking about solving in a quadratic, we have to do box and diamond. So when we do box and diamond, we are going to end up with so go ahead and do box and diamond on your own. You should be able to factor that without me going through it. And we will get x plus 4 and x minus 1. Now remember, the zero product property rule, the ZPP. That means that one of these has to equal 0 if it's going to equal 0. So we set each one equal to 0. And then now we have two linears. So I'm going to subtract 4 from both sides, minus 4, and I'm going to add 1 to both sides. Okay? Now I end up with x minus 4 or x plus 1. I'm not done. I have to plug both answers in. So I'm going to go ahead and do that. I'm going to check -4 first, and then I'm going to check 1. Alright? Everywhere I see an x in that original equation, I'm going to replace with a 1. I'm sorry, a -4. So this is why I use a parentheses right here. Right here. Because look at, I got 4 minus -4. Well, 4 minus -4 is 5 plus 4, which is 9. So then I get the square root of 9 is equal to -4 plus 1, which is -3. So the square root of 9 is equal to -3. Well, the square root of 9 is 3. 3 cannot equal -3. So this is not one of the solutions. Alright, so now I'm going to do that with 1. So I get 5 minus 1 is equal to 1 plus 1. So then I get the square root of 4 is equal to 2, and 2 does equal 2, so that is true. Oops. 2 does equal 2, so that does equal true. Alright, and so then we'll say our solution set is 1. On the test, I'm expecting to see this. I want you to write all of it out, and I want you to show me which one is true. I am expecting that for progressing, meeting, and exceeding, or advanced. Okay, so we're going to go through this one again. Our radical is already alone, so we're going to go ahead and take it, and we're going to square both sides, because when we square both sides, that undoes the square root. Okay, I have a binomial. Binomial. That should make you think, I need to put that in a box. So when I do, I end up with 1 minus 2p minus p squared is equal to p squared plus 2p plus 1, which is great because now I've got my quadratic, and I'm going to add p squared to both sides because I want to keep my p positive, and if I subtract I won't. I'm going to add a 2p to both sides, and I'm going to subtract 1 from both sides. And that makes this one 0, and I get 0 is equal to 2p squared plus 4p. Well, I should look at that and think, oh, I can factor out a 2p. So I'm going to do greatest common factor for my factoring. and I end up with 2p times p plus 2. Now, the zero product property says we take each factor and we set them equal to 0. So I'm going to take 2p, so a factor is something we're multiplying, so 2p is equal to 0, and p plus 2 is equal to 0. I end up with p is equal to 0, or p is equal to negative 2. Alright, I'm going to plug those in. I get 1 minus 0 is equal to 0 plus 1. The square root of 1 is equal to 1, so we're good there. How about this one where I plug in a negative 2? Again, I'm going to use those parentheses because the second one becomes a positive 4, but this becomes a negative 4, so we have to be careful. Negative, and I end up with the square root of 1 is not equal to negative 1. So my solution set is 0. Alright, I'm going to go through this example on a different video. So make sure that you do this. All of these questions are typical questions that will be on the test for solving. So make sure even this one you get on. So go to the next video. Thank you guys.